This is Outrageous History. Hello, I'm Ernest Granson, and welcome to Outrageous History. In the 1950s and 1960s, the Cold War years, paranoia and secrecy flourished within the Eastern and the Western hemispheres, each fearing the other had developed or was in the process of developing the most deadly military weapons on the planet. Those circumstances were largely behind the formation of a secret Lockheed Martin company division, nicknamed the Skunk Works, officially known at that time as Lockheed Advanced Development Projects. That division was responsible for the design and manufacture of some of the most advanced aircraft in the world, including the P-80 Shooting Star, which was the first operationally used U.S. jet fighter, along with the A-12, the SR-71 Blackbird, and the F-117 Nighthawk stealth aircraft. Skunk Works was an unusually structured unit operating outside the main corporation framework and led by aeronautical engineer Kelly Johnson. Both Skunk Works and Johnson went on to attain almost legendary status. To tell us about this unique entity is Jay Millar, a Texas-based aviation photojournalist who has written numerous books and articles and is considered an expert in just about every aircraft there is. Jay's book, Lockheed Martin's Skunk Works, is the first and only official history of the Skunk Works. Hi there, Jay. Thanks for being with us today.
Ernest, thanks. Again, happy to be on board and talk about a subject near and dear to my heart.
Well, Jay, I think there's several really striking aspects of the Skunk Works. For me, it's not only the incredible technology of these aircraft that emerged for that era, but also the environment in which the development of the aircraft took place. Take us through the history that led to this unique situation.
Well, I think it wouldn't hurt to cover a little bit of Lockheed's history from the early days. The company was effectively put together by three brothers about 1913, and that was Victor Lockheed was one of the better known, primarily because of a book he had authored in 1909 called Vehicles of the Air. And that effectively put him on the map. The other two brothers, Malcolm and Alan Lockheed, they were actually the airplane-oriented side of that operation rather than simply putting out textual materials for reference. And their very first aircraft was a little biplane that was effectively a float plane that met with basically no success, even though it was a reasonably good aircraft for its era, and that was 1913, 1914. But very briefly, the company went through a number of iterations, and that included at least three bankruptcies. And by 1926, there was an effective re-establishment of the company that the three brothers had originally intended it to be, and that is the historically the official beginning of Lockheed as we know it today. Because from 26 on, even through the Depression, the company survived. And in part because it was savvy, or at least its directors were savvy at hiring very competent engineers. And the first of those was a fellow by the name of Jack Northrop. His real name was John, but for one reason or another, people called him Jack. And Jack was the founder later on of a company called the Northrop Aircraft Corporation, which in turn evolved over a period of about a half century into today's Northrop Grumman Corporation, which is one of the largest military industrial operations in the world. Anyway, Jack Northrop went on to become famous for his flying wing airplanes, but during his period of time with Lockheed, he also created two of Lockheed's most famous and most successful aircraft during a very, very difficult period of time during the Depression. The first of those was the Model 9 Orion, which was a low-wing monoplane, mostly wood construction, and very high performance for its era, capable of speeds in excess of 200 miles per hour. But perhaps more famously, that he also developed Lockheed's most successful airplane of the era, and that was the Lockheed Vega. The Vega went on to set many world speed and altitude records, including the very first, took 8 days, but the first around the world flight, and that was piloted by Wiley Post and Harold Gatty, and that occurred during the mid-1930s. Also very famously, Lockheed Vega was the airplane that Amelia Earhart used to make the very first crossing of the Atlantic Ocean by a female pilot. And again, that was early in the 1930s as well. Now, having said all of that, the company knew that their future did not lie with single-engine wooden monoplanes. And under the auspices and the umbrella of Hal Hibbard, who was the vice president and chief engineer of the company, they embarked on a program to build a twin-engine, all-metal airplane, which became the Lockheed Model 10. And before the construction of the first prototype, they went to the trouble of building a scale wind tunnel model, and they shipped that to the University of Michigan for wind tunnel testing. Because the University of Michigan, even at that time in history, had a very competent, well-established, and very competently run aerospace engineering. What's now an aerospace engineering, but in those days it was just aeronautical engineering department. And somewhat serendipitously at that time, they had a student by the name of Clarence L., nicknamed Kelly Johnson. Kelly was born in Ishpeming, Michigan in 1910. And in 1933, by the time Lockheed basically hired him, he had matriculated through the University of Michigan and had not only an undergraduate degree in in aeronautical engineering, but also 2 post-undergraduate degrees, 2 master's degrees, again in aeronautical engineering. And I don't remember for sure now what the second aeronautical engineering degree was in, but it was a subset of the original. Mm-hmm. So the point being that though he had gone to Lockheed for employment prior to his receiving his postgraduate degrees, the company had basically, Hal Hibbard, who was to be his boss through his many years during the early days of Lockheed, Hal Hibbard is the one that recommended he go back to Michigan to complete his postgraduate studies. And at the time, there was a professor there at Michigan, and trying to remember his name. Anyway, the professor and Lockheed had interfaced with each other during the course of the development of this twin-engine airplane. And he had said basically that based on wind tunnel results there at Michigan, that the airplane was basically ready to be built and test flown. Well, concurrent to that, Kelly Johnson, being an undergraduate at that time, had been assigned by that professor to review those wind tunnel results, and Kelly Johnson disagreed with his professor. And that got back to the folks at Lockheed, and they proposed to Kelly that he come up with a solution to that problem. And what he eventually came up with was 2 vertical tails. It's called a H tail assembly, and basically do away with the original design, which only had a single vertical tail surface. There's a little bit more to the story. I don't want to get into it too deeply, but the point is that the people at Lockheed, particularly Hal Hibbard, the chief engineer, was very impressed with Kelly Johnson's assessment. And when the airplane was finally built, it was built with twin vertical tails. And as Kelly Johnson had predicted, it flew well. Well, at that point, they officially hired him and brought him on board. By now, it's 1933. And that design, the Model 10, progressed through the Model 12 and then later the Model 14. The Model 14 actually survived long enough to be a very successful airplane from a military perspective during World War II. And in turn, it was still followed after the war by other iterations of that same basic design, which said a heck of a lot about how good Kelly was as an engineer.
He was quite audacious to make that kind of suggestion, as well as being an undergraduate. But it seemed that he had a lot of expertise in that wind tunnel testing while he was at the university.
Well, Michigan was a little unusual in having a full up wind tunnel, and Kelly, was prescient enough to understand what a privilege that was, and that's one of the reasons he picked Michigan, which at that time was arguably, outside of MIT, probably the foremost aeronautical engineering studies program, or offered the best aeronautical engineering studies program of any university in the country, and arguably in the world. And even today, as we speak, Michigan is still pretty much the epicenter of providing, the U.S. aerospace industry with top-notch engineers. Other engineers that went there, for an example, would be Harry Hilliker. And Harry is not nearly as well known as Kelly, but Harry is the father of what today is Lockheed Martin's F-16 program. And the F-16 is arguably the best fighter of the 20th and probably pretty deep now into the 21st century. Anyway, so Kelly, became Hall Hibbard's right arm. Again, I'm being a little repetitious, but Hall was the vice president in charge of engineering. But over the course of the Model 10 program, the rumblings of war on the horizon began to be felt here in the United States. And many of the, and there were quite a few aircraft companies during this period, were sensitized to the fact that the military was going to need new combat aircraft in order to be competitive, if you will, in any combat scenario. And there were a number of military authored requirements for new pursuit aircraft. Fighters in those days were referred to as pursuits. And Kelly basically on a napkin sat down one day, and this is in the mid to probably 36, 37 is when this occurred, sat down and on a napkin began to sketch out what became Lockheed's preeminent fighter of World War II, and that was the P-38 Lightning. And this was a major program, and Kelly Johnson effectively, in all intents and purposes, fathered what became one of the great fighters of the war. And P-38 was a very unique design, and it was twin boom construction, twin engine, reasonably fast for its era, though not extremely fast. It was capable of about 400 miles per hour, and had the unique configuration of having everything concentrated in a pod in the center section of the wing that was between the two engine nacelles. And the reason that's important is that it allowed all of the armament, all the guns, to be located in the nose of that podded fuselage section. And in turn, there were no issues of let's just be very basic about it, how do you synchronize the bullet to go through the prop arc? And that was an art that was finally perfected during World War I by Anthony Fokker. But regardless, it simplified that process, and it actually lightened the airplane somewhat because a synchronizing mechanism was not required to be installed on the engine to compensate for the guns shooting through the propeller arc. That was a relatively minor issue, but it was one of some importance. Most importantly for the P-38, it had exceptionally great range for a pursuit aircraft. And where it was used the most during the war, though it was actually used in almost all the theaters, but its attribute of great range was of considerable importance because it was used a lot in the Pacific theater of operations. And a lot of the sorties that were flown by P-38s were flown over water, and pilots felt that the great range and having two engines was a safety factor that could not be ignored. In truth, historically, twin-engine airplanes are effectively no safer than single-engine airplanes, but there was that psychological advantage of having that second engine out there. Anyway, the P-38 went on to great success. Kelly Johnson got a lot of credit for that. But most importantly, in 1943, the advent of jet-powered aircraft was beginning to be felt throughout the military services. And I say felt because the Germans were actually the first to perfect an operational, production-worthy turbojet engine. And in so doing, they were also the first to create a truly operational and combat-worthy jet-powered fighter, and that was the Messerschmitt Me-262. Other jet fighter aircraft had preceded the Me-262, but it was the first one to actually go into service and into combat. The British had a jet-powered fighter during that period of time, and here in the United States, based on British engineering, using a Frank Whittle designed jet engine, we built and test flew an airplane called the XP-59. And that airplane was developed by Bell Aircraft Corporation from Niagara Falls, actually Wheatfield, New York. So, but when all was said and done, the P-59 was not an effective combat aircraft. And of the 50 plus airplanes that were built, almost all of those were used for training purposes and never served in actual combat. But it was well known that the P-59 did not have what it took to become an effective fighter. And so the Air Force basically made a decision to explore other options. And at the very top of their list for consideration was Lockheed. Kelly Johnson tackled that program. The end product was the XP-80, which became America's first successful jet-powered airplane. Now, I have left out of all of this equation, everybody's probably wondering, well, where in the hell does the Skunk Works come into this? And the P-80, which again was born in 1943, is also the representative birth date airplane for the beginnings of the Skunk Works. And because of the secrecy that surrounded almost everything military during World War II, the P-80 was of particular concern in terms of secrecy because of its proposed capabilities. And so everything was done very hush-hush at Lockheed. But one of the requirements that Kelly Johnson had, and these ended up being the foundation for the Skunk Works that we know today, was that he and his team would have absolute control over absolutely everything that went into that airplane. In exchange for that privilege, he guaranteed delivery of that airplane in 150 days. And so from start to finish, the XP-80, which at that time was technologically one of the most advanced airplanes in the world, from start of the program to the time the airplane was rolled out was 150 days. It was actually a few days fewer than that. So the P-80, because of the secrecy, was built as a separate entity from the standard Lockheed production process. And they literally set up in a, it wasn't even a permanent installation there at the Lockheed plant in Burbank, California. It was made out of canvas, and it was supported by a wooden structure that was of limited structural integrity. You know, if a hurricane or a tornado or something had moved through Burbank, that probably wouldn't have been the first thing to go. But everything was done in that little facility. In my Skunk Works book, which I'll talk about more maybe a little later, I do have some references on that are of considerable interest, and that was how all of that went together. But the point being that the P-80 was completed in a very short period of time. Milo Burcham made the first flight in the airplane in 1943. I'm trying to remember the exact date on that, but it was successful. And they had moved the airplane for that first flight from Burbank. They had loaded it on a flatbed trailer, and they had trucked it out to Muroc Army Airfield. Muroc is today's Edwards Air Force Base. And the beauty of that facility is that it was remote, and it was a dry lake bed that was some 15 miles of effectively runway. It was basically mud flats that had dried, and they were just perfectly smooth and ideally suited for this type of flight test work. The P-80 was not the first airplane to be tested at Muroc. Other airplanes had been flown there on and off for many, many years before the advent of the P-80 program. But anyway, the P-80 went on to be a modestly successful fighter. It was later, during 1948, all the aircraft were given new designators. All the pursuits, for instance, became fighters. And so the P-80 became the F-80. And it was successfully used during the Korean War. And then a developed version, also created in the Skunk Works, was the T-33, which became one of the primary jet trainers of the 1950s and on into the early 1960s. Now, I left out the little part about how the name of the Skunk Works came to be. And basically, that was a scenario wherein a fellow by the name of Irving Culver, who worked for Kelly in the P-80 facility, came into a habit of, on occasion, answering the phone. Hello, this is the Skunk Works, and that was spelled S-K-O-N-K, and it was based on the cartoon character. It was a Little Abner was the series, and Al Cap was the cartoon creator. And for a while, that was a bit of a joke around the facility, but over time it caught on, and it was particularly of interest to Al Cap because he felt it was a trademark and effectively a copyright infringement. And he made mention of that and made sure that Lockheed understood that. So at a later date, they converted the S-K-O-N-K to S-K-U-N-K, and they trademarked and copyrighted that. The trademark lay in the cartoon that was used and is still used today. Lockheed owns all of that. They own the cartoon of the little caricatured skunk, and it has become a classic trademark item in the history of not only the Lockheed Martin Skunk Works, but throughout the aerospace community here in the United States.
Jay, I just curious about the management for Lockheed. How did they feel about Kelly Johnson's? Well, it was almost a demand that that division operate under his own schedule and conditions.
Well, first of all, Kelly and Hal Hibbard, the vice president of engineering, were close friends. And Hal Hibbard was a very fortunate scenario for a man like Kelly Johnson because Hal Hibbard fully understood that he was dealing with, in the most literal sense, great aeronautical genius. And so he was sensitive to Kelly Johnson's requests to the effect that he knew that they were not frivolous and that there was rationale to anything that Kelly would ask him for. And as that would prove to be such a fortunate situation where Hall Hibbard knew and understood that, and he backed Kelly at every corner whenever something like this popped up. And in the many years to follow, it paid off for Lockheed in spades. And there came a point where, in effect, there was nothing that Kelly Johnson asked for that he could not get from the corporate leadership at Lockheed. And over time, and there did come a point wherein ADP, you did say it correctly, today it's Advanced Development Programs. In those days, it was Advanced Development Projects. But over time, the importance of that small division at Lockheed not only kept that company alive because of Kelly Johnson's innovative work, but the philosophies that Johnson espoused were bled over into other companies. And as we sit here and speak today, all of the major aerospace companies in the United States have their own versions of the Skunk Works. So it set precedent for every other major aerospace corporation here in this country. As an example, here locally, Lockheed Martin locally, which is not different from Burbank, but it is a separate unit. They have their own separate version, an independent version of the Skunk Works. And at the same time, even Bell Helicopter has something called the X Works, where they do innovative and advanced technology programs. Now, I am leaving out some important issues, and one of the things that the Skunk Works became very, very famous for, and this is one of the reasons that Kelly came up with his philosophies on how to run his little independent part of Lockheed, is that he did not want any bureaucratic crap to stand in the way of getting these airplanes built and flown. After that, you could do whatever you wanted with them. But if you gave Kelly Johnson an assignment and you said to Kelly that you needed it by such and such a date, it happened. It was just that simple. He could go out and buy any part, any engine, any quantity of a particular type of metal. As you probably are well aware, the SR and the A-12 predecessor that were built of titanium. Titanium was very difficult to get. It's used primarily in those days. It was used primarily for turbojet engine components. But Kelly, when he went out there and said, I need X number of, hundreds of tons of titanium, it appeared at his doorstep almost magically. There's a very famous story about Kelly and the way government money was sent to the Skunk Works. And not everyone knows this, but it's gone around for years. And then I had the privilege of actually seeing the object of this little story. And that is that Kelly Johnson's house had a little mailbox out in front of it. Every major checks, in the hundreds of millions of dollars, went through that mailbox at Kelly Johnson's house before it was cashed by Lockheed. And that little mailbox was just Clarence L. Johnson, whatever the street address was there. And again, I had the privilege of visiting the house and spending some time in Kelly Johnson's office, but that's a long story. Anyway, that little mailbox is very famous. And I think in the collector's market amongst aviation aficionados, it'd probably be worth a small fortune. But to the best of my knowledge, it still sits out there in front of Kelly.
It's almost unheard of.
Yeah. And
I guess his importance really became apparent as they moved into those Cold War years when all of that tension was heating up, and eventually wound up with those super aircraft designs.
Let me get into that fairly quickly. The P-38 carried Lockheed through the war, but then the post-war period, as was the case with most of the aerospace companies, they were hurting from government contracts. There's general consensus of opinion is there would be no more wars, and we wouldn't have to have all of these highly advanced, very expensive combat aircraft. But as time would tell, that would not prove to be the case. But in the interim, there was a period of time where basically the Skunk Works existed only in effectively name only, because the programs that were being assigned to the Skunk Works are actually being collected by Kelly Johnson to bring into the Skunk Works in order to keep it as an extant entity inside of Lockheed as a private, not private, but a separate, independent part of the company's operations. So they brought on board a number of airplanes. An example would be the F-104 was developed in the Skunk Works. Not many people know, but the Lockheed C-130 was developed in the Skunk Works. An airplane called the XFV-1, which was a vertical takeoff and landing fighter. There was even a little twin-engine airliner called the Saturn that was built inside the Skunk Works. Anyway, a long list of little projects like this just to keep the Skunk Works alive and the people who work in the Skunk Works employed. And I do want to, when I mention that, I do want to say too that was another thing about Kelly's operation. The people who worked there, the numbers were limited by Kelly Johnson. It was a lean and mean operation. During the design and development phase of the XP-80 and the construction phases of the XP-80, et cetera, a maximum of 200 people did all of that. And that's for stuff. And if you compare that to today's Lockheed Martin, as an example, our F-35 production line here in the Fort Worth area, they employ 18,000 people. And it's just mind-bending. And that's just the operation that's going on in Burbank right now with Lockheed. There are thousands of people employed there.
Well, did that number of 200 include the actual manufacturer of the plane?
Absolutely. Yes, it did. Now, I'm not talking the production P-80s because those came later and those were shifted over to the main production line at Burbank. But just the design and development creation of this one prototype airplane employed 200 people. That may sound like a lot, but particularly based on today's requirements for doing something similar, there would be thousands of people involved in that project. So anyway, he was very good about that. And I want to mention one other thing about Kelly Johnson, one of his other requirements, and this is of interest. There were no documents, no drawings, no spec sheets, nothing that is a normal requirement for the development of a prototype airplane. None of those bore the word secret on them. And there was a bureaucratic reason for that, and Kelly was smart. He understood that. The moment you put that word secret on a document inside of a company like Lockheed, the bureaucracy involved becomes extraordinary, and it is a barrier to getting things done because it limits who can look at a document and who can't look at a document. And Kelly knew that if they imposed that on what they were trying to do inside the Skunk Works, there would be engineers who would be allowed to see one document, other engineers who would not be allowed to see one document. And he understood where those walls could create serious problems in getting things done in a timely fashion. Now, whether that holds true to today, I don't know. I kind of doubt it because I think, when Kelly died in 1990, at the age of 80, I proposed to you at that point, that was the end of an era at the Skunk Works. Kelly was out of the system by then. His position effectively had been filled by his right arm, a fellow by the name of Ben Rich, who I'll talk about momentarily. But anyway, but let's get back to after that slump period, if you will, in the history of the Skunk Works. A fellow by the name of John Seberg, who was an Air Force, I think either colonel or lieutenant colonel, and who I had the privilege of interviewing many years ago. John Seberg, during the course of World War II and in the post-World War II era, had begun to understand that there was a need for high altitude reconnaissance. And there was a lot of reconnaissance that went on during the course of World War II, but it was not given the emphasis and the level of importance that it rightly deserved. And so Seeberg had done an analysis of this and had noted that the Germans, during the course of the war, had begun to develop onesies and twosies of airplanes that were optimized for high altitude reconnaissance, to get over combat zones and to do it safely. And in those days, an airplane that could get to 40 or 50,000 feet was a rarity. But the Germans did develop an airplane, I think it was the Junkers Ju-86, that was capable of cruising at about 45,000 feet. And it was optimized to carry cameras and take pictures of targets on the ground that were of interest to their military commanders. And over time, knowing the state of the art in technology, Seeberg proposed that they develop a high altitude jet-powered reconnaissance airplane. And he argued for that in the Pentagon and eventually met with some success and got some support. And over time, the idea of it and the practicality of it and the foreseeable or projectable attributes of being able to access that kind of information began to really resonate with a lot of the people in the intelligence divisions of the U.S. government. And what they came up with was a program that would lead to a high altitude reconnaissance airplane. And interestingly enough, there were 3 competitors for that. Lockheed was not one of those. But those 3 competitors were Martin, which is somewhat ironic because today that's the same company that is the Lockheed Martin. Anyway, there was Martin, there was a company called Fairchild, and then most importantly, Bell Aircraft Corporation, which was, again, located in Niagara Falls. Bell ended up winning that contract, and the end product of that was an airplane which not many people know about called the X-16. And it was a high aspect ratio, mildly swept wing airplane with 2 specially built J-57 engines. And it had an altitude capability of 68,000 feet, at least on paper. That airplane, for point of conversation, was 3/4 of the way finished. The prototype was 3/4 of the way finished at Bell's Niagara Falls plant when they got a call one day and said, your program has been canceled. And that, to all intents and purposes, became the beginning of the end of Bell Aircraft Corporation, a company that had started in 1935 and had been very successful building P-39s and P-63s during World War II. And then they went on to build the XP-59. And they also were the fathers, if you will, of the Bell X-1 that Chuck Yeager broke the sound barrier in October of 1947. And then they developed a whole fleet of other exotic experimental airplanes. But experimental airplanes don't pay the bills of the big aircraft company. So they were on their way out of business. And sure enough, by the 1980s, in terms of being aircraft manufacturers, they were out of business except for their helicopter division, which ended up being here in Fort Worth. Anyway, another long story I won't get completely into, but here's the important part. The X-16 had laid the groundwork for a high altitude reconnaissance platform. Kelly Johnson got wind of that from some buddies of his at the Pentagon. He knew that if he went to the Pentagon and said, hey, I can build something better than that, it would be futile because the the X-16 was too far along at that point in history. So he took a different route, and he had friends in the Central Intelligence Agency, one of which was a guy named Richard Bissell. And he went to Bissell, and there was also, I can't remember Land's first name, but he's the father of the Polaroid camera, among other things. I think it's Edmund or Edward Land. Anyway, he went to those men and proposed an airplane called CL-282. And the CL-282 was basically an F-104 fuselage with new high aspect ratio wings. And these high aspect ratio is basically the wing chord dimension relative to effectively the length of the wing. And the higher the aspect ratio, the more efficient a wing is operating in very thin atmospheres at very high altitudes. Anyway, his airplane, the CL-282, even though the X-16 was far down the pike, his airplane became the center of focus of the Central Intelligence Agency because they understood the attributes of high altitude overflights of target areas. And what that high altitude gives an airplane is protection, because conventional fighters, particularly of that era, we're talking the mid-1950s, could not begin to reach altitudes of 70 and 75,000 feet, where these new high altitude optimized airplanes were going to operate. Kelly basically won the CIA over. They ended up getting a contract to build, I think, 20 or 21 airplanes. It was signed off by no less than President Dwight Eisenhower, and they went ahead to build the first of the U-2s. Now, there is some question over how they wound up out in the desert in Nevada for testing these airplanes. The rationale, of course, was to get out of the public eye. They didn't want anyone to know about the U-2 program. And as a result, Richard Bissell, Kelly Johnson, and Lockheed's chief test pilot, a fellow by the name of Tony LaVere, got into Tony LaVere's personal Beechcraft Bonanza and spent several days flying around Nevada looking at all the dry lake bed sites. And at that time, there was a nuclear, and it still exists today, there was the nuclear test facility where they literally tested nuclear weapons. But you need to keep in mind that in those days, they were still testing them above ground, not below ground like they do now. So that was a concern, but the bottom line was the best place they found was called Groom Lake. And Groom Lake was simply a dry lake bed. It was huge. I don't remember now the mileage, but for point of conversation, it was about 15 or 20 miles from one end to the other. And they eventually picked that site, which is now part of Area 51. You hear that name tossed around a lot, but it is an official name for a big it's a big square that accommodates that part of the nuclear test range. And they set up shop there on that desert. And I still remember during spending some time with Tony LaVere and him talking about that. He said when they landed there at Groom Lake for the first time, he said there were old cans from the old wagon trails that went across that Groom Lake area, and they were old tin cans, rusted out and what have you, that had dates from the very early 1900s that they all sat apparently and talked about for a while after they had landed. And it took them quite a while, by the way, to basically walk most of that. I'm not talking about Kelly and Tony and the but anyway, they didn't personally walk it. They hired a team later on to clean up the lake bed for this flight test program. Anyway, so they set up shop out there, and the first prototype U-2 was delivered out there in a C-124 in disassembled state. And then Tony LaVere made the first flight of the airplane in 1955. And then over a period of time, the very first 10 lightweight U-2s were placed in service by the Central Intelligence Agency. They were delivered over initially to Germany, to a base there in Germany, and then the initial overflight programs began. I don't want to go into too much detail because the history of the U-2 program is far too complex to relate in a relatively short interview like this, but suffice it to say, the U-2 was a very successful high-altitude reconnaissance program, and it goes on today as we speak in a second-generation version of the airplane called the U-2R and the U-2S, and there's also a U-2T out there, but that's another story. Anyway, they built 55 of the first-generation U-2s. The most famous, of course, was the airplane that Francis Gary Powers was flying on May 1st, 1960, when he was shot down. And that was, I believe, and don't quote me on this, that was only the fifth or sixth, maybe the seventh overflight of Russia, which was a really big deal at the time when it happened. Gary Powers' airplane was, a lot of stories have gone around over how it was shot down, but the reality is they used basically a shotgun approach. They had tried to shoot down other U-2s unsuccessfully, but they decided to do a multiple launch of surface-to-air missiles. They were called SAM-2s, which was the state-of-the-art surface-to-air weapon that the Russians had at that time. And because they did a multiple launch, and I don't remember, I think 11 separate missiles were fired at the same time. One of them, the warhead exploded in close proximity to Gary's airplane, probably did serious damage to the empennage section, which included the vertical and horizontal tail surfaces, and the airplane basically came apart. It does bring up one little thing I'll mention. The U-2 was a very, very, very difficult airplane to fly. And in fact, without an autopilot, it could not be flown. And the reason is that the U-2 at very high altitude gets into something called coffin corner. And that is where the airplane is operating at its critical Mach number. And at the same time, it's operating right at its stall speed at that altitude. And we're talking 70 to 72,000 feet. Now, what that means is a critical Mach number, and I'll simplify it, is to say that an airplane will come apart because it's not structurally set up to exceed that particular number. Conversely, the stall speed is when the wing starts failing to give lift. And so you're in that little 5 mile per hour box between critical Mach number and your stall speed. And if you get outside that box at any point in the flight, you're going to come down. That's all there is to it. You'll either come down in pieces or you will simply stall out and come down out of control. So anyway, he was flying in that coffin corner when this weapon blew up near him. And so the airplane was already on the verge of being unstable. And when the explosion occurred, that was it, knocked it out of the sky. Anyway, as everybody I'm sure who is interested in U-2s knows, Gary Powers survived. It became a major political incident. Eisenhower was basically forced into making a number of concessions. And when all was said and done, there was a famous trade for Gary Powers using a Russian spy who'd been caught here in the United States. Anyway, so enough about that. Again, there's the U-2 story in and of itself we could talk for hours about, but there was a second generation, as I mentioned earlier. They used the name U-2 on both generations of the airplane, but in truth, the U-2R, which is the second generation airplane, was a totally new airplane. It has very little to do with the original U-2, though most lay people don't understand those differences. As an example, the original U-2 had an 80-foot wingspan. The U-2R has a 103-foot wingspan. The U-2A versions, and there were U-2A through H's built. Anyway, the U-2R has an altitude capability of 75 to 78,000 feet. The U-2As were good up to about 72,000 feet. The U-2R carries a much heavier payload. And again, it's still operational. I think there's still 37 or 38 U-2Rs in service as we speak.
So those U-2, that U-2 generation is still going on. What would have led then to the development of those further stealth aircraft?
Okay, that's where I was jumping next.
Mm-hmm.
So because of the U-2's vulnerability, as time evolves with these things, countermeasures to them are developed. And the Russians weren't blind to the fact these airplanes were overflying their country. And so they made a decision to develop two things: A, more effective surface-to-air missiles, but they also basically reached an accord with the Mikoyan-Gurevich Design Bureau in Russia, and that's MiG for those of you who don't know where the name MiG comes from. Anyway, the MiG Design Bureau began development of an airplane that eventually became known as the MiG-25. And its sole purpose initially was to have an altitude and speed capability, not only to reach the altitude of the Lockheed U-2, but they also were aware of the development ongoing in the United States to build an airplane that flew higher and faster than the U-2. And that airplane started out inside of Lockheed, and this was not a sole source contract, and not a lot of people know about this, but there was a General Dynamics, which is a predecessor to today's Lockheed Martin. There was a General Dynamics program calling for the development of an airplane called Fish, and that was an in-house code name for the program. But Fish, and it's a program I've now been privileged to study in great depth, and probably have more information on that program sitting here in this house than most lay people will see for the next 50 years. The point being that it was designed to cruise at 100,000 feet at a speed of 4.2 Mach, which is a full Mach number faster than the SR-71. It differed in many ways from its competitor, and I'll get back to the A-12 in just a minute. It differed in many ways from the A-12 in that it used different materials for construction. And the reason is that even though there was only one Mach number difference in the maximum speed, the heat issues that were created by the increased friction at that higher speed demanded the use of more exotic materials. And over the course of the history of the competition, that was one of the deciding factors on why the Central Intelligence Agency elected to go with Lockheed's more conservative design. As an example, in the Fish and Kingfish programs, they use something called pyroceram, and that's a very high temperature, sustainable, effectively a plastic resin, but it can handle the temperatures that were generated by flying at 4 times the speed of sound. Now, that was the Fish program. The Fish was powered by a ramjet engine. It would have been carried to altitude by a modified B-58 Hustler. B-58 was a supersonic bomber capable of Mach 2, and it had a very unusual landing gear because it carried a pod underneath the airplane, and that pod would be replaced by the Fish reconnaissance aircraft. It would have been carried to altitude, launched by the B-58, overflown its target area, and then come back on its own power, which in the early versions of Fish actually included 2 small turbojet engines, which would pop out from the fuselage and give it enough power to get back to its base of origin or some other base that's off-site. Anyway, the agency reviewed both the programs. Fish and Kingfish were honchoed by General Dynamics version of Kelly Johnson, and his name was Robert Widmer, and Widmer is another one of the great aeronautical engineers of the era, but unfortunately largely forgotten to history, primarily because he worked in so many classified programs that no one even wanted his name to be circulated. But back to the Kelly Johnson A-12 program, Kelly and the Skunk Works team began work on this airplane to replace the U-2. They went through a long series of design studies that evolved through the A-1 through the A-11, and A stood for Archangel, and that was the in-house code name for the program. Anyway, the A-1 through A-11 proved unsuitable to meet the mission requirements. Concurrent to all of this, complicating things, and we're back to the pyroceramics in the General Dynamics Fish and Kingfish programs. Concurrent to all of this, it had been discovered very early on in the U-2 program that the airplane was visible and trackable by Russian radar. And so they wanted to include in this new project for a high-speed, high-altitude airplane what's now called low observables technology, and more in terms of layman's terminology is referred to as a stealth capability. They wanted to reduce the radar cross-section of the airplane, i.e. reduce the amount of radar generated energy that contacts the target and is bounced back to the radar's receiver. And so what you see when you see today's SR-71 is an airplane that was partially optimized for that, though not perfectly, and a long way from the technology to reduce radar cross-section that we have today. So the first iteration of what became the SR-71 was an airplane called the A-12. It was built only for use by the Central Intelligence Agency, and initially it was considered to be the airplane that would replace the CIA's U-2 fleet. And the A-12 was conceived in 1959, and it made its first flight in 1964, and it was operational a year and a half later. And again, 15 airplanes were built. One of the interesting and little known facts about the A-12 is that it was actually faster than its successor, the SR-71. It differed from the SR-71 in that it had only one cockpit. The SR-71 carries 2 crew members. Again, the A-12 only carried 1. So it was a 3.35 Mach capable airplane. The SR-71 is a 3.25 Mach airplane. For the layperson, the difference is about 2,100 miles per hour for the SR-71, about 2,250 miles per hour for the A-12. Because the agency used the A-12 and the agency doesn't give a damn about world speed records, A-12s were never used to attempt to set a world's absolute speed record, even though they were very much capable of doing that. They were only operational for a few years, and then the agency made a decision to basically get out of the overflight reconnaissance business, where they were overflying countries like China and Russia and North Korea, and the list goes on from there. I won't get into the optical packages, the sensor systems, and what have you. Again, those are stories that are too long and complicated. I will just tell you that the quality of the optical imagery gathered by the U-2 and gathered by the SR-71 actually differed quite a lot. Though the SR-71's cameras were capable of producing very good images, the SR-71 suffered from a plasma flow issue that impacted the quality of the optical imagery, whereas the U-2, being a subsonic airplane, did not have that problem. So from the SR-71, which stayed in service until the early 1970s, a few airplanes were retained by NASA and used for various and sundry test programs by then. But effectively, the airplanes were moved from the active inventory during the late 1980s, and they are now, all the A-12s, the surviving A-12s, a number of those were lost in accidents, I might add, and also the surviving SR-71s, almost all of those now are on display in museums. It's interesting to me, I'm a big fan of aviation museums and have been privileged to visit over 150 around the world. The places I've been where SRs are on display and A-12s are on display, invariably I overhear conversations when they see an A-12, everybody's always talking about the SR-71, and I'm always sorely tempted to tell them that you're looking at a much more unique airplane than the SR-71 when you're sitting there, for example, in San Diego at the San Diego Air and Space Museum. The airplane that's sitting outside the museum on a plinth is an A-12. It is not an SR-71, and it's a much more significant airplane because it was the first jet-propelled airplane in history with a person on board to fly at 3 times the speed of sound. So from those programs, Lockheed moved on. Basically, the next major front, if you will, for aircraft technology was to develop an airplane that was invisible to radar. And I use that word invisible very loosely and in a very broad spectrum way. No airplane, no vehicle of any kind is totally invisible to radar. But the mission objective was to reduce the radar cross-section as much as possible. And this is where Ben Rich steps into the picture, and effectively Kelly Johnson steps out. In 1990, Kelly died. He was in Burbank when he passed away. And he did not die from any horrible disease. He did have dementia by then and was suffering from other minor ailments, but age had simply caught up with him. He was 80 years old. He had lived a very stressful life, I might add, been through 3 marriages. The first 2 wives had passed away from natural causes. They had been successful marriages. His 3rd marriage to Nancy, who I had the privilege of knowing, survived his demise. And last I heard, Nancy is still alive, but I could be wrong about that. Anyway, just as a side note, all of Kelly Johnson's wives worked for Lockheed at one time or another. So anyway, so Ben Rich now steps into the picture. He is the acting director of the Skunk Works when Kelly Johnson died. And he has been very active for many years with Skunk Works at this point. He is the man who basically created the propulsion system for the A-12 and the SR-71. Is a master engineer, brilliant guy, a wonderful person. And he takes over in the middle of their attempts to develop an airplane that's impervious to the effects of tracking effects of radar. And so their first foray into that was something called HAB Blue. And HAB Blue was a very small test bed airplane. They built 2 of them. And HAB Blue used a system that actually, and this is somewhat ironic, had been developed by a Russian engineer in Russia. And that is to use a faceted surface on the outside of the airplane. Now, what you need to imagine is that if you were to take a mirror and mount it on a stick, and then suspend it between 2 posts, somewhat along the lines of taking a piece of meat and putting it on a stick, putting it on a fire, and you slowly turn it. If you took that mirror and then you stood off in a dark room with a flashlight and you aimed it at that mirror, as it rotates, there would only be short periods of time as that mirror goes around when you would see a reflection back at you from that flashlight. And if you understand basically what I'm trying to say there, you are also suddenly understanding what the F-117, which is the big full-scale version of HAB Blue, was all about. And a lot of people have puzzled over how awkward the F-117 looks, and it's all because of those faceted surfaces. They don't look very aerodynamic, and that is simply true. It was not a very aerodynamic airplane. If it wasn't for fly-by-wire flight control systems, and then the one that's in the F-117, it was actually an iteration of the system used in the fly-by-wire F-16. If it wasn't for that, the F-117 would not be able to fly. And I won't get too deeply into that. Let's just say that it was an aerodynamically unstable airplane, and without computers, it could not have been controlled. So anyway, HAB Blue proved the point that the faceted surfaces would work. You could take an F-117 or its predecessor, HAB Blue, fly it through a radar scenario, and yes, you would catch glimpses of the airplane on your radar, but that's all it would be. It would never be enough where you could lock onto the subject airplane and track it and fire a weapon at it. So that was the rationale behind that design. They eventually built 43 F-117s altogether, and they did enter operational service. They were usually kept in at Tonopah Air Base in Nevada, and then sent out on their operational missions from that facility. During the first few years of the flight test program of the F-117, which incidentally took place at Groom Lake, the same place where the U-2 and then later the SR-A-12s and the SR-71s were flight tested. Actually, I just told a little bit of a lie. The SR-71 made its first flight from Palmdale, but all the A-12 flights were done at Groom Lake. Anyway, F-117s were operational, actually used in combat on a couple of occasions with modest success. I think one airplane was lost in combat. I do not at this point really remember all the details, but to the best of my knowledge, that was the only loss, at least from enemy action. There were a couple of other losses that had nothing to do with that, but just simply mechanical issues at one level or another. So following that, Lockheed embarked on a program to develop a new fighter, which was the F-35, which is in production as we sit here and speak. They were also very intimately involved in the development of the F-22 and its predecessor, which was a smaller design called the YF-22. The F-35 was preceded by a test bed as well, and it was called the X-35. And there were two X-35s built and two YF-22s. So those airplanes, both the F-22 and the F-35, are now operational in the U.S. Air Force. They incorporate a new, what is referred to as a fourth generation stealth technology. That involves materials. It involves, yes, the external design of the airplane while reducing the radar signature. And very importantly, it involves basically what are called coatings. And if to simplify it, a coating is literally a paint that you spray on. In this case, it's not truly a paint, but it is a material that attenuates the reflection of the radar energy and reduces the distance that when it is bounced off of the subject airplane, it doesn't go back to the receiver part of the radar as readily, or it comes back as a much weaker signal than it would if the aircraft was not coated. So, and that incidentally, the coatings can be traced all the way back to the A-12 and SR-71 program. That's when they were first used. The difficulty with those two airplanes, incidentally, is that because of the speed of the airplanes at Mach 3, there's a pretty high temperature that builds up, and it was hard to develop coatings that were both effective as radar reduction coatings and also as a protection from the heat that was generated by the airplanes at Mach 3.
Now, you mentioned that a lot of other corporations implemented that very a similar type of format as the Skunk Works. What is the current state of the Skunk Works right now?
Can't tell you. Actually, I'll give you a brief overview. Things have changed a lot in the past 2 decades, and everything that is going now, and it's not just with Lockheed Martin and not just with Lockheed Martin Skunk Works, all the major companies, their orientation is basically unmanned systems. And I made a prediction probably 20 years ago at the beginning of the F-35 and the X-35 predecessor programs. I made a prediction on television that the F-35 is potentially the last manned fighter that will ever serve in the U.S. military. And to date, I have not been proven wrong. And I'm not patting myself on the back. I think a lot of other people saw that coming as well. And I could be wrong when all's said and done. There may be one more manned fighter to make it into the operational inventory, but I don't think I'm going to be in that prediction. So to hark back to your original question, most of what Lockheed Martin has going on now, except for some little one-off prototypes, most of what they're doing now is in the form of unmanned vehicles. And they've been very successful in that. I will go so far as to tell you that Lockheed Martin, before it absorbed the General Dynamics operations here in Fort Worth. Lockheed Martin inherited the fish and kingfish legacy that I mentioned early on. And that's important because that was important technology in terms of airplanes capable of flying at 4 times the speed of sound. And the reason I bring that up is that, and I'm not sure how deep to get into this, but at that time, they were also looking at building a reconnaissance platform, an airplane with a crew that was capable at flying at, and if you're sitting down, 9 times the speed of sound. And to give you a little...
With a crew.
That's correct. That was a maximum speed of almost 6,000 miles per hour. And so Lockheed inherited all of that, all of the studies that were involved, and the design configurations, the propulsion systems. You know, just to want to build an airplane to fly 6,000 miles per hour is no simple issue. It's not a matter at that point of materials technology. It's also a matter of coming up with a propulsion system that functions in an atmosphere. I'm not talking in space, that functions in an atmosphere and can sustain flight for long periods of time at 6,000 miles per hour. As we sit here and speak, there is nothing in the public domain about propulsion systems in the atmosphere that function at 6,000 miles per hour. Yes, there have been scramjet tests. That's a supersonic combustion ramjet, which interestingly enough has no mechanical parts other than fuel injectors. And there are other ramjet technologies that have been explored. But most importantly, Lockheed has a public domain patent, and you can look it up, for something called a pulse jet.
Oh, yeah.
It's not a pulse jet from World War II as it was used in the V1. This is a scenario where they inject fuel, they ignite it, it explodes and goes out the back end of the airplane. And they do that rapidly, at very high rates, you know, maybe for conversation's sake, 1,000 explosions a minute, maybe more. But each one of those explosions potentially develops thousands upon thousands of pounds of thrust. And it requires only a very refined air intake to make all of that work. There are no mechanical parts. You're just injecting fuel. You have a little spark plug effectively that ignites it. And then the air that's coming into the intake is compressed sufficiently to permit enough oxygen to get to that fuel to allow the ignition to take place.
So that type of advanced research and development continues to take place then in that kind of a company?
Absolutely. It's going on every second of every day as we sit here and speak.
Can I just ask you one final question here, Jay? As far as you're aware, what kind of manager and colleague was Kelly Johnson?
I talked to a number of people over the years. Sadly, I never had the actual privilege of shaking Kelly's hand myself. I think I mentioned to you in our earlier conversations that when I was researching the history of the Skunk Works for the book, I was invited by Nancy to visit Kelly's house and to spend some time in his office. And he did have a modestly good-sized office in his house. And to sit in Kelly's chair at Kelly's desk and have Kelly's original handwritten diaries placed in front of me by Nancy to reference was one of the great privileges of my life. But to more directly answer your question, quite a few of the Lockheed people I talked to had worked under Kelly, and most notably Ben Rich. And none of them ever had anything negative to say about Kelly. He was a hard driver. He was a great salesman, and his success in the Pentagon and the CIA just says everything needs to be said about that. He was not a particularly gregarious person, in that he was an engineer first, and everything else was secondary to that. But if he made a recommendation, or he sat down in a meeting and had a discussion with his teammates, he was all ears. He listened to what they had to say, and then he would chew on it and give them a response back. And 99 times out of 100, if he had some changes to make or suggestions, they bore fruit positively for the end product. So I wish I could speak with more authority from the standpoint of having spent time with Kelly, but though we corresponded, I never spoke to him over the phone, and I never shook his hand. Ben Rich, I can tell you, became a very good friend. And when Ben died, we had been actually discussing that much. I say that because we were close enough friends that we could talk about personal things like his illness. He had esophageal cancer, and he called me the day he discovered he had it. In fact, he had just walked out of the doctor's office. So that's how good we were in terms of, or close we were in terms of our friendship. Kelly's influence, there were many great engineers in this country. We've been privileged here. Theodore von Karman. I mean, I can give you a list, Warner von Braun, and even the Wright brothers, Burt Rutan. I mean, the list is so long. But at the very apex of all of those great engineers is Kelly Johnson. This is Jay Millar's opinion, and it's worth what it costs you. But unlike a lot of people, I have studied all these people. I've written about them. I've written about their airplanes. But Kelly was unique. I mean, just the rules for operating the Skunk Works, they've become the industry standard. And this was done in the 1940s. And so much of what he did circulated out throughout the aerospace industry here in the United States, but beyond the United States. There are now Skunk Works at Dassault, at the Tupolev and Yakovlev and Mikoyan and Sukhoi design bureaus in Russia. I know because I've been there, and I've seen those things in operation. I see what they're doing. And all of them, whether they're conscious of it or not, can trace what they're doing back to Kelly Johnson. And it's just amazing. There's only been the one book written by his secretary, as one of his secretaries anyway. It's just incredible to me that there has not been a definitive biography written about Kelly Johnson. I will tell you one little thing that happened quite a few years ago. I got a call one day from a producer for a movie company, and they had read my Skunk Works book, and they wanted to make a movie about Kelly Johnson in the Skunk Works. And they flew me out to California. In fact, I took Susan, my wife, with me. And the ironic thing is that, and I laugh when I think about it, they couldn't find anything about his love life. I mean, he was just a perfect husband. He loved his three wives. He never did anything, to make for an interesting story outside of that, his married life. And the conclusion that as a person, he was just too boring. didn't have anything to write a story about. So that ended that project.
Well, it is amazing how much impact Kelly Johnson, Skunk Works, and Lockheed in general has had, not just on the aviation industry, but globally. And so I really appreciate you telling us about that, Jay. Thanks for spending time this morning.
Oh, thanks, Ernest. More than welcome.
And thanks to all of you for tuning in to this edition of Outrageous History. I'm Ernest Granson, and we'll see you again soon. Outrageous History is produced by Northern Flicker Media.